Okay, so this is our last lesson for chapter 5. We're just going to go back and revisit parallel and perpendicular lines and their properties. So first of all, I want you to graph the line y equals negative 2/3 x plus 1. So let's recall how to do that. Y-intercept is 1, slope is negative 2/3, down 2, right 3, plot my second point and connect. And there's my line y equals negative 2/3 x plus 1. On this same grid, I want to sketch a second line that's parallel to this line, but I want it to pass through the point 0, 6. So if it passes through 0, 6, I start marking that point. From there, my slope is negative 2/3, down 2, right 3, and connect. And there is my second parallel line. Equation of that line, slope is the same, so y equals negative 2/3 x plus my y-intercept is 6. Now what I want to do is I want to sketch a line, a third line, that's perpendicular to our original line, and I want it to pass through the point 0, negative 4. So let's remember, perpendicular lines have slopes that are negative reciprocals of each other. So I'm going to start with my y-intercept, which is negative 4. The original slope is negative 2/3. I want the perpendicular slope, which means I'm going to change from negative to positive, and I'm going to flip my fraction. So I end up with a new slope of positive 3/2. So from the point 0, negative 4, I'm going to rise 3, run 2, plot my second point, and connect. And there's my third line. Perpendicular, so I'm going to indicate that right there with a right angle, right? Perpendicular lines intersect at 90 degrees. And for my equation, again, the slope is the negative reciprocal of this, so it becomes positive 3/2. Y-intercept is negative 4. Put those 2 points together, and we end up with our equation y equals 3/2x minus 4. So let's draw some conclusions. Well, just nothing new. We're just recapping from the chapter and previous ones. Parallel lines always have the same slope, but they have different y-intercepts. Perpendicular lines have slopes that are negative reciprocals of each other. Now, negative reciprocals means I flip the fraction and I change the sign. So if I'm starting with the slope of 2/5, the perpendicular slope will be negative 5/2. Starting with a slope of 1/4, perpendicular slope will be negative 4. My original slope is negative 2/3, perpendicular slope will be positive 3/2. My original slope is 3 over negative 5. My perpendicular slope will be positive 5/3. And we don't actually put in that positive like I did there. I was just trying to reinforce that, okay? My original slope is negative 1/9. My perpendicular slope will be positive 9/1, and we don't write 9/1, we just write that out as 9. And finally, if my original slope is 6, that's 6/1, right? My perpendicular slope will be negative 1/6. So what is new, we haven't seen this previously, the product of our original slope and our negative reciprocal slope will always equal negative 1. And that's just an interesting fact. So my original slope is negative 2/5. My perpendicular slope is 5/2. If I multiply those together, I end up with negative 10/10, which is negative 1. And we can check that with another slope. If I have an original slope of positive 7/4, my perpendicular slope will be negative 4/7. Multiply these two fractions together. Negative 28 over positive 28 gives me negative 1. Okay, so I'm going to give you a series of lines. I want you to tell me, are they perpendicular, are they parallel, or are they neither? So set A, we've got y equals 3x minus 5, y equals 1/3 x plus 3. So I'm looking at my slopes. Well, this slope is 3/1, this slope is 1/3. They are reciprocals, but they're not negative reciprocals, right? They're both positive. So these are neither. They're not parallel, and they're not perpendicular. Set B, my first slope is 3, my second slope is negative 1/3. These are in fact negative reciprocals of each other, so these two lines are perpendicular. Set C, my first slope is 2/7. My second slope is also 2/7. Notice they have different y-intercepts here. These two lines are parallel because they have the same slope. Set D, y equals negative 8/13x. So my slope is negative 8 over 13. My second line, y equals 13 over 8x minus 7. All that I'm interested in are the slopes. So negative 8 over 13, positive 13 over 8. These are negative reciprocals of each other, so these two lines must be perpendicular. Finally, my last set, y equals 7 over 2x plus 5, y equals 7 over 2x plus 5. So looking at the slopes, yes, they are the same, which tells me that my lines are parallel, but in fact, my y-intercepts are also the same. So what that means visually, if I were to draw these out, I wouldn't have this case here, where I have no solution to parallel lines. I'd have this case here where one line is lying right on top of the other line. So yes, they are parallel. They are the same because they have the y-intercept, which means I have an infinite number of solutions. Remember we talked about this previously when we were looking at intersection points? We said two lines can intersect once, they can intersect never if I have this situation, or they can intersect an infinite number of times if I have this situation right here. So for homework, again, the focus is on analyzing slopes here. I'd like you to look at these questions on page 302. As always, reach out to me if there are any questions and I will get back to you as soon as possible. Have a great day, everyone.